of power supply. Okay, voltage scaling means you have to reduce the power supply or reduction of the corresponding actual power supply voltage. That is a voltage scaling. Okay, so in low power design is a very important criteria or important factor in a CMOS circuit. Okay, so one of the very important method for reduce the power dissipation is called as the reduction of VDD. So that is called as low power design through voltage. Okay, so now we have to see the effect or influence of voltage scaling on the power and delay. So what is the relationship? So we have to understand that concept, then only we go for what are the methods is available for the low power design through the voltage scaling. Okay, so the first we can see the reduction of power supply. What will happen is it reduces the dynamic power dissipation. So we know the expression for the dynamic is V dynamic is equal to, that means okay, so what is the expression? C load, that is load capacitance into VDD square. Okay, so VDD square into the frequency, that is frequency, clock frequency. Okay, so here the dynamic or average power dissipation is directly proportional to the supply voltage. So when you are increasing the supply, the power dissipation increases. When you are reducing the supply voltages, the power dissipation, overall power dissipation will be reduced. Okay, so that is a low power design through the voltage reduction, power supply, the reduction of voltage. Okay, so now we have to see what will happen when we are reducing the power supply, what will happen on the delay. Okay, so now we have considered the CMOS inverter circuit. So what is the expression for the propagation delay for the input is low to high as well as high to low? Okay, so already we know the inverter circuit. So in an inverter circuit, it contains one PMOS as well as one NMOS. Okay, so the normally the NMOS is connected to VSS and PMOS is connected to VDD. The gate terminal of input is connected to gate terminal is connected to input, and we have to get output here itself. So here the switching transient, that means the input is from high to low as well as low to high. There are dynamic power dissipation when the switching transient, that is the input changes and output changes, it occurs the power dissipation, that is called as the dynamic power dissipation. Okay, so here the expression is denotes the propagation delay relates with the high to low as well as low to high. That means the input is high, output is low. Okay, so when the input is high means the NMOS transistor is on condition. Okay, so here when NMOS transistor is on, some of the charges is discharges through the NMOS transistor that will be reaches to the ground. So hence the output is low. So that is a transition between high to low. So the propagation delay is expressed in terms of C load divided by Kn VDD minus VTN into 2 VTN divided by VDD minus VTN plus natural logarithm of 4 VDD minus VTN divided by VDD minus VTN. Okay, so that means here the propagation delay high to low, the NMOS transistor is on condition, that will be is related to this expression. Okay, so from this expression we can understand here the delay is, it will be inversely proportional to the supply voltage. That means our aim is we have to reduce the supply voltage VDD. So when you are reducing the supply voltage, what will happen? The propagation delay will be increasing. Okay, so that is the main factor. When you are going to increase the delay, what will happen? The performance, switching performance will be reducing. That is, speed of the circuit will be reducing. Okay, so we have to compensate the delay. That means when we can reduce the supply, at the same time how to reduce the delay also. So that will be is compensated by compensating the threshold voltage. Okay, so in this method we have utilized two kinds of circuit to compensate the threshold voltage for the low supply voltage, that is reduction of VDD. At the same time we have to reduce the delay also. Okay, is it clear now? So here at the same time we can consider the propagation delay for low to high. Okay, so low to high means input is low, output is high. So the input PMOS transistor is going on condition, so the VDDs it will be get to output, the capacitor will be charged. Okay, so here, so this propagation delay is related to the threshold voltage for PMOS transistor. This propagation delay is related to the NMOS transistor. Okay, so in both the cases, when you are going to reduce the supply, the delay will be increasing. So we have to compensate the delay by compensating the threshold voltage. So that is a technique for getting low power design through the voltage scaling by reduction of delay, at the same time reduction of the supply voltages. Okay, so here in this expression we are putting the threshold voltage is magnitude, that is modulus value, because the threshold voltage for PMOS is negative, for NMOS is positive. So that's why it will be putting modulus. Okay, is it clear now? Say yes or no. Okay, so now we go for the relationship between the voltage low power design through voltage scaling by understanding this graph. Okay, so here listen. In this one, here the supply voltage. When the power supply voltage increases, what will happen? Our dissipation will be increasing. Okay, so we have to reduce the power dissipation. Okay, so we can reduce the supply voltage. For example, here the supply voltage is 2. What will happen? The delay will be increased. That is a interrelation between the power dissipation by the reduction of power dissipation and also the delay. Okay, so our aim is we have to compensate the delay. Okay, so by keeping the supply voltage is reduced for power supply voltage, at the same time to reduce the delay also. Okay, so that is a method for obtaining the low power design by through the voltage scaling by adjusting the threshold voltage of transistor. Okay, so that it having two different methods is there. Okay, so another thing is the dependence of the circuit speed on the power supply voltage may also influence the relationship between the dynamic power dissipation and the supply voltage and the switching frequency. What is switching frequency means? So normally we know that the dynamic power dissipation is equal to load capacitance into VDD square into frequency. Okay, VDD square into frequency. So here the frequency is also, it will be directly proportional to the power dissipation. So by keeping this this frequency, clock frequency is as a constant value by reducing the power dissipation. That is also one criteria for the designing of low power dissipation by the reduction of supply voltage. Okay, so how it will be getting means by reduction of the VDD, at the same time we have to reduce or compensate the threshold voltages. At the same time we have to reduce the corresponding delay. Okay, so that is a method for getting the corresponding low power design. Okay, so here listen. So in this graph, yeah, it will be give some relationship between the power supply voltages as well as the delay. Okay, so that means we are already understanding when we are going to reduce VDD. Okay, we are going to reduce the so when you are reducing, yeah, so listen, when you are reducing VDD, okay, so from the propagation delay expression, when you are reducing VDD, that is supply voltage, it will increases the delay. Okay, so increases the delay. Okay, that is down. Okay. So that will be is compensated by changing the threshold voltage. So that is a method to attain the low power design by, that is we have to change or reduce the threshold voltage. Okay, so to change the threshold voltage, it is a method to attain the low power design through the voltage scale. So that will be is analyzed in this. Okay, so here we have to see the supply voltages increases. What will happen? The delay will be, when supply voltages increases, the delay will be decreased. Okay, so our motto is we have to reduce the supply voltage. Okay, so when you are reducing power supply, what will happen? The power distribution will be reducing. At the same time, what will happen? The delay will be increasing. So how it will be compensated? The delay means by reducing the corresponding threshold voltage. Okay, so when you are, for example, VT is equal to 0.8 voltage, what will the delay? Delay is between 12 to 14. Here VT is 0.6 means 8 to 10. Here 0.4 means 6 to 8 and 0.2 means 4 to 6. Okay. So we are considering that when you reduce the delay power supply, the delay will be increasing. The delay is compensated by the changing of or compensating the threshold voltage of NMOS as well as PMOS transistor. Okay, so that will be is obtained by using two methods. The methods are called as the variable threshold CMOS, VT CMOS, as well as multiple threshold CMOS. Okay, so here, so in these two methods, here to obtain the corresponding low VT as well as low VD circuit. Okay, so in these two methods, it has some difficulties in space, so that will also analyzed in this two methods. Okay, so variable threshold CMOS is denoted as VT CMOS, multiple threshold CMOS is denoted as MT CMOS method. Okay, so now we have to see the variable threshold CMOS. Okay, so now in previous thing we already decided we have to obtain the low power dissipation by the reduction of supply voltage. It is denoted as low VDD as well as low threshold voltage. It is denoted as low VP. Okay, so it is a efficient method for reduction of the overall power dissipation at the same time for the maintaining high speed performance. Okay, so here in a CMOS, for example, if you consider this kind of approach is, it will be implemented in that CMOS logic circuit. Means what will happen means the corresponding sub-threshold leakage will be increasing. Okay, so when increases the sub-threshold leakage, so sub-threshold leakage is one of the second order effect. So here due to some reason, that means the threshold leakage timing the threshold voltage of NMOS and PMOS transistor, it will be a